In 1.6, we're going to talk about measuring center, the center of a distribution. So here's the travel times in minutes of 20 randomly chosen New York workers, along with a dot plot of the data. So these are their travel times to work and a dot plot. The distribution is right skewed and single peaked. The longest travel time, which is 85 minutes, appears to be an outlier. There's a gap there. So how should we describe where this or some other distribution of quantitative data is centered? Okay? The two most common ways to measure center are the median and the mean. Hopefully you've heard these words before. We could report the value of in the middle of a distribution as center. That's the idea of the median. Median is the midpoint of a distribution. The number such that about half the observations are smaller and about half are larger. To find the median, arrange the data in the values from smallest to largest. If the number of data points is odd, then the middle is the middle, and that's the median. If the number of data points is even, the median is the average of the two middle values, okay, in the ordered list. So that should ring a bell from previous years. How to find median. Line them up in order and find the middle. Now, mean is the most common measure used for center. And mean, we use the symbol X bar. We pronounce X bar. Of a quantitative set of data is the average of all data values. To find the mean and all the values, you add all the values and divide by the number that you have. That's the common average that you know of that you've done before. In mathematics, the capital letter sigma is short for add them all up. Therefore, the formula for the mean can be written in more compact notation, looking like this. We add up all the data points and we divide by however many we had. Don't worry about this formula too much. Go with what you know as a common average, and you'll be fine. Now, which measure, the mean or the median, should we use as the center of a distribution? Both are center measurements. Well, it depends on the shape of the distribution and whether there are any outliers. And the reason it matters is because of something called resistance. A measure of center or variability is resistant if it is not influenced by an unusually large or unusually small values in the distribution. The mean is not resistant to outliers. It tends to go the direction of the outliers. The median is resistant to outliers. Okay? So here's a dot plot, and you can see the measure of center is that red triangle right there. Okay, measure of center. It's not exactly the middle, but it's the measure of center. Okay? So let's talk a little more about this. So in choosing a measure of center, if a distribution of quantitative data is roughly symmetric and has no outliers, you use the mean to measure the center. So look at this first one right here, or the middle. This one's a roughly symmetric distribution. And notice the value of the mean, basic average, is 15.78. The median, if you go old school and you line them up, least to greatest, and find the middle, the median is 15.8. Notice that these are very much the same, or almost identical, really. So mean equals median if it's symmetric. Now, if the distribution is strongly skewed or has outliers, we use the median to measure the center. All right, because look what happened here. If this is left skewed, meaning the tail's on the left, look, the mean, which used to be the same as the median, gets pulled towards the tail. If it's left skewed, it gets pulled down, so it's going to be less than the median. So our better measurement of center is the median if it's skewed. Now, if it's right skewed, it means the mean is greater than the median because the mean is going to get pulled towards the tail, which is to the right. Right? So it's important that you catch these diagrams. If it's left skewed, then the mean is less than the median because it gets pulled to the left. If it's right skewed, the mean is greater than the median because it gets pulled right. If they're symmetric, they're equal. All right, let's do an example. Joey's first 13 quiz grades in a marking period are listed below. Listed here. Find and interpret the median. All right, so the rules say you line them up in order from least to greatest. So let's do that real quick. Least is 73. So 73, 7, 2, 3, 80. All right, they're lined up in order, and I find the middle. So I take one off each end until I get down to the middle. So the middle is 83. So I would say the median is 83. Now this is a big deal. It says find, we found it. Interpret the median. Interpret means you're going to have a full sentence. So we would say about half of Joey's quiz scores are less than an 83. About half are greater than 85. Okay, or 83. So when you're asked to interpret, make sure you put a full sentence in context. Okay, you will be asked to find it and interpret. Don't forget both parts. Now, a shortcut to this, I'm going to show you, has to deal with number 2. Still, Joey's first 13 quiz score grades in a marking period are listed here. Calculate Joey's mean quiz grade and show your work. Now, you could add them all up and divide by 13, but I am going to show you a trick on your calculators. Okay, so look at this. Here's your calculator. Turn it on. When you turn on your blank screen, now notice the Stat button right here in the center. If you hit Stat and enter, edit, it's going to pull up some lists, and you're going to use this list a lot in this class. You're going to put the quiz grades in that list, and I've already done that for this example. Okay, so if all the data is in the list, then the calculator will do the work for you. So you would go, once you got the data in there, you go to Stat and over here to Calc, and one variable statistics, the very first option. Hit click, enter. List 1, leave the frequency list alone. You don't really need anything there, and hit calculate. And it's going to generate these values for you. So notice, and the very first thing it gives me is that X bar. Remember, X bar means mean. It's the mean of our sample. So the calculator's done it for me. You're going to use your calculator to do that for you. So the X bar is 84. Okay, and you don't really have to show a lot of work for that. I know it's going to ask you to. But there it is. Now, if you wanted to know median, if you see that arrow right there on the bottom left, if you scroll down, there it is. The median is 83. Okay, so there's one way to do median. You can do it by hand. Either way works. But the calculator will give you the mean and the median. So the mean is the X bar symbol, and median is down here where it says MED. Okay, so you need to write down these calculator steps so you have them. So let me remind you what they are. You're going to go Stat, Edit, and then you're going to enter data into L1, and then you're going to go to Stat, Calc, one variable, statistics, and then make sure you choose list 1. So in this case, what was the mean score? It was X bar equals 84. All right. So B, Joey has an unexcused absence for the 14th quiz, and he receives a score of 0. Recalculate the mean and the median and explain why the mean and the median are so different now. So notice that 0 would be a major outlier. And so if all of our data is like over here, 0 is way down here. So our mean and our median were pretty close. The median was an 83 and the mean was an 84. So let's think for a minute. The mean gets pulled towards the outlier, so the mean is going to come down. So the mean would be lower than the median because it's getting pulled down. It is not resistant to outliers. But let's find out exactly what it is. So if I go back to my calculator, go back into my list, Stat, Edit, and I'm going to add a 0 to that list. There it is. I'm going to add 0. And then go back out to Stat, Calc, one variable statistics, and then hit calculate. Look what happened to my mean. It went all the way down to 78. It is definitely less than what's before. So the new mean is 78, and the new median, see what would happen to our median. Median should stay pretty much the same, which it was 83 before. Look at that, it's 82.5, so it's pretty close. So explain why the mean and the median are so different now. Okay, before the 0, the distribution was roughly symmetric. The 0 makes it skew right. So the mean smaller because it is not an outlier. Okay? So mean gets smaller because it got pulled towards the outlier. Alright? Let's look at another one. One of the important factors in determining population growth rates is the birth rate per 1,000 individuals in a population. The dot plot shows the birth rates per 1,000 individuals for 54 hours. Okay? Explain how the mean and the median would compare. All right, so we got to think about the shape here. What is the shape doing? Our shape does this, right? It's not exactly symmetric. It is pulling towards the left, so it's left skewed. That means my mean is going to be less than the median. Okay? So we would say the mean be less than the median because the mean pulls toward the long tail, the left distribution. All right, that's why. The mean is going to be less than the median. Now, which measure of center better describes the typical birth rate? Well, because it's skewed, we have to use median. It's non-resistive. Okay? That's it. The median is better. Median is the better measure of center of this distribution because it is left skewed. All right? So hopefully that makes a little sense. Mean and median, you got to know when and how to use them for measures of center.